This is the first and only video for lesson 8-5, problem solving with trigonometry. And really all it does is it takes the topics from 8-2 and puts them into word problems. That's really the only thing. This lesson is just entirely on word problems and introduces a couple new, only two new concepts. So it's a reasonably short lesson. So just going to go over these two concepts and then we'll jump into a few examples and that'll be it. Alright, so 8-5, problem solving with trigonometry. So before we begin the word problems, first we have to look at these two new concepts, this new vocabulary. Angle of depression and angle of elevation. Literally the only two concepts, new vocabulary, new concepts. It's important that you understand them because if they use these terms, you need to know how to identify them. The definitions and some examples begin on page 2 of the PDF file. And I think they're pretty straightforward. All right, so your angle of depression is an angle formed by a horizontal line and the line of sight to an object below the horizontal line. Okay, and then the angle of elevation is an angle formed by a horizontal line and the line of sight to an object above the horizontal line. So both of these angles, angle of depression and angle of elevation, they're based off of a horizontal line. It's just that one opens upward, the other opens downward. All right? Line of sight, just think about, what you're looking at. The line of sight. So again, angle of depression, so an example. If we make a horizontal line, If I have this horizontal line and then the angle opens downward, then that's your angle of depression. All right, so if I have this horizontal line and then from this end over here, then this angle would be considered an angle of depression. Okay, because again, definition, an angle formed by the horizontal line and a line of sight to an object below the horizontal line. So this is below, depression, down. So some ways to think about it. So for example, as in the example on page 2, you have the observation deck. That's in the observation deck, some building. So you use a T shape, keep it simple. So if you're standing right here and you're looking down at, say, another person, this is the street. If you're up here and you're looking down at somebody that's on the ground, well, then your line of sight creates an angle of depression with the horizontal. Now your angle of elevation, well, we can again think about like what we were talking about with sine, cosine, and tangent, perspective. If we change it over to the person on the ground, so now let's make a horizontal line here. So then the person down here, let's call this person A and this is person B. So person B forms an angle of elevation because here's their horizontal line right here and their angle their line of sight is to an object above the horizontal line. So here's your horizontal line. The line of sight opens upward. It's above the horizontal. So from person B's perspective, we have an angle of elevation. Person A, we have an angle of depression. Okay, so that's the difference between the two. Again, angle of depression opens downward from the horizontal. Angle of elevation opens upward from the horizontal. Okay. And so, again, you have some examples on, beginning with slide 2, 3, and 4. The answers are already there, so now it's really just a matter of, looking at the answers and understanding why those angles are described as they are. Again, one of the important things to remember with angles of depression and elevation is they are all based off of some horizontal line. Okay, so again, every angle is made up of two sides. With angles of elevation and depression, one of those two sides will be horizontal, must be horizontal. So let's move on to some examples here, and we'll look at 4 different examples. Because in some cases, these word problems can be a little tricky. Okay, so these videos really help if you're following along with the PDF, because it's going to take a little bit too long to write down the questions. So you want to be following along with the PDF. So this example here is going to be from page 5. And we'll do both problems. Number 1 and number 2. Okay, so number 1 says, for a reverse bungee ride, Reagan stands halfway between 2 vertical posts. 2 bungee cords extend from the top of the post to Reagan's waist at a height 1 meter above the ground, at an angle of elevation of 70 degrees. How tall are the vertical posts? Okay. So if you look at the image, usually what helps is to recreate the image. That's a simplified figure. With everything that you see, it can be a bit of a mess. So let's simplify everything. Okay. It says the posts are vertical, so we know they make a 90-degree angle. Okay, so over here we'll label this point R for Reagan. And we can call this T for the top of the post, and right here B for the bottom of the post. Something else we don't want to forget is that, well, let's use these 2 blocks here. That represents 1 meter. Okay, we know that this is 70 degrees because the question said that the bungee cord, which is represented by the hypotenuse here, extend from the top to Reagan's waist at a height 1 meter above the ground. So this right here is the ground. Alright, so from Reagan's waist, the angle of elevation is 70 degrees, so that's how we know this must be right here. It's labeled in the picture, but it helps to understand why we're here. Alright, so now we are also told that Reagan stands halfway between the 2 vertical posts for this reverse bungee ride. So if Reagan is standing halfway between, we know that the distance from the post to Reagan's waist, or to Reagan, must be 4 meters. So from the post to Reagan's waist, that's 4 meters. So what are we trying to solve for? You know, that's how we answer any question. We have to know what what are we looking for? What do we know? We want to find out how tall these posts are. So remember, height is determined. This is the distance from the ground up. So that's what we're looking for. Also, we need this distance right here. So how do we do that? Well, let's think. We can't use Pythagorean theorem. We only have one side. But we have one side and one angle. So we can use trigonometry. Well, let's see. We have our right triangle, TBR. We have 70 degrees right here. The length we are interested in is TB. So how does this one relate to the 70 degrees? Well, that's the opposite side. We know we have our hypotenuse over here. The bungee itself is the hypotenuse. So then the 4 meters, that's the adjacent side. So since we're interested in the opposite side, well, then that means cosine, let's see, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. We don't have the hypotenuse, we don't care about the hypotenuse, so sine and cosine, don't need them. We rely on tangent. Okay, so then the tangent of 70 degrees opposite, well, that's the side we're looking for, so let's just call that x, divided by the adjacent, which is the 4 meters. So then, just like we discussed at the beginning of 8-2, if you don't recall how to solve this type of problem, refer back to 8-2. Our variable x is divided by 4, so multiply both sides by 4. Let's cancel out. And x is equal to 4 times the tangent of 70 degrees. So now we use our calculator. 4 times 70 tangent is equal to 10.9899096.8. Which rounds to about 11 meters. However, this would not be the proper answer. So we're looking at the height of the meter. We can't forget that the bungee cord is tied to Reagan's waist, 1 meter above the ground. So the actual height of the posts is 11 plus 1. So the posts are approximately 12 meters in height. And see, these are the kinds of things you need to be on the lookout for when it comes to section 8-5. Okay, so that was example 1. Let's move on to example 2. In example 2, you have a house, and the question reads, to what angle of depression should the security camera be adjusted in order to have the lens aimed at point P on the ground? Okay, so to what angle of depression should the security camera be adjusted in order to have the lens aimed at point P on the ground? Well, for that one, let's start with a triangle. Okay. So we are told that the camera is going to be placed 6 meters from the ground, from the base of the house. Let's call this up here point C. Point G for the camera. And then we know that that's point P over here. Okay, so the line of sight from the camera is given to us as 12 meters. Again, since we're talking about the angle of depression, I want to make that horizontal line here. Because this is the angle we want. At first glance, you might be thinking, well, what does this angle have to do with this triangle? Like, what's going on here? Well, there are two ways to look at this. This triangle here. And part of it involves parallel lines. Remember, angles of elevation and depression are based off of some horizontal line. So in these real-world situations, unless you're told otherwise, the ground is treated as being level. If the ground is level, that means it is horizontal. So if the ground is horizontal and the line and the angle of depression or elevation is based off of a horizontal line, well, two horizontal lines have a slope of 0, and since they have the same slope, they are parallel. So if these two lines are parallel, then the line of sight from the camera to point P functions like a transversal. So if the line of sight is the transversal of two parallel lines, well then the angle of depression must be congruent to the angle of elevation from the perspective of point P. So that's one way you could look at it. Or you can take the angle of depression over here, the horizontal line, and make a secondary triangle to point P. Point C, and we'll call this point I, say I for an imaginary point. That's all I can think of at this moment. Well, the distance from I to P will be the same from C to G, 6 meters. Okay, so those are two different ways to set up this problem so that you have a right triangle and you can solve for the angle. Now, again, Pythagorean theorem, that's not going to help us find the angle measure. So we need to use our inverse trigonometric functions. So I'm going to use triangle CPG over here. Well, let's see, how do these sides relate? Well, if angle P is over here on the bottom left, angle of the 6 meters is the opposite side. And then 12 is across from the 90-degree angle, so that's our hypotenuse. So sine, cosine, tangent, which one involves opposite and hypotenuse? Opposite, hypotenuse. So if we look at our scribbled out answers over here, opposite and hypotenuse. So we're going to use sine, or rather inverse sine, since we are solving for the angle measure. So we can just leave it as x, or you can call it angle P. That's up to you. I'm going to go with x. So x degrees will be equal to the inverse sine of opposite over hypotenuse, inverse sine of 6 divided by 12. So the calculator does the rest. So 6, in this case I'm going to use the fraction button, 6 over 12. Okay, I'm in degrees. We're going to use inverse sine, so I have to press second first. There's my second. Inverse sine, so right here. And this one is actually equal to 30. So that means we've been dealing with a 30, 60, 90 triangle. Now, we could have actually skipped the inverse trigonometric, problem solving process here. if we notice that we're dealing with a right triangle where the leg is half the length of the hypotenuse. So that's why it helps to have a well-rounded understanding of all these special right triangles and properties and such. So sometimes you can find other ways around it, simpler ways around it. Now, will this happen every time? No, that's just something to point out. And we have one leg of the right triangle, half the length of the hypotenuse. Since it's a right triangle where the leg is half the length of the hypotenuse, we know it must be a 30, 60, 90. So since the short leg is half the length of the hypotenuse in the 30, 60, 90, that's how it's one other way we could have solved for the angle measure and determined that it was 30. So secondary method. Alright, so let's move on to the next two examples. Just to do a couple more. Let's just do one more actually. Yeah. Number 1 on page 6. Number 1 on page 6 says, an amateur astronomer sets up her telescope in the center of a circular field. The field is surrounded by trees 20 meters tall. The tripod holding the telescope pivots 1 meter above the ground. What is the lowest angle of elevation to the nearest degree at which the astronomer can observe a star? Okay, so we know we're going to use a right triangle. So how do we work this out? Well, so some of the information that you're given in the image. Well, we know that the trees are 20 meters tall. So then if this point right here, let's call this the ground. So G. T for tree, or you can think top of the tree. And over here we can call this point A for the astronomer. And so we know that the distance from T to the ground must be 20 meters. Okay. Now, again, this is not pictured here. It's pictured on the PDF. The circular field, the field where the astronomer is standing, is 100 meters in length. Now, it is also mentioned that it is circular. So if the astronomer is standing in the middle of a circular field, well, then that means she's standing in the middle of a circle, the center of a circle. And if this is the center of the circle where the astronomer is standing, then point G would be a radius of the circle. The radius of a circle is half of the diameter, so this distance must be 50 meters. Alright, so everything looks like it's in order. Or is it? Well, one thing we don't want to forget is that the tripod is pivoting 1 meter above the ground. So my triangle here is actually not set up correctly. It's actually not set up correctly. Because if the telescope is 1 meter above the ground, then we are not actually dealing with the full height of the trees. Alright? So from the astronomer, we're actually, again, G represents the ground, but again, the telescope is not on the ground. It is 1 meter above the ground. So let's actually move that. Let's use red. Let's say this red marking, actually, this red marking right here let's have that represent 1 meter. So if we connect that over here, so where the astronomer is standing, red triangle would be a more accurate representation of what we're working with. So let's redraw this, because now again, since we're not working with the full height of the trees, because the telescope is 1 meter above the ground, the actual height that we're working with is 20 minus 1 is 19. So let's use this space over here to redraw our triangle, so we're not dealing with this mess over here. We'll keep our variables the same just for the sake of simplicity. So here's the astronomer, telescope, trees, and again we have to relabel this distance as 19 because we are working 1 meter above the ground. Horizontal distance remains unchanged at 50 meters. So 19 meters, 50 meters. So now we can figure out what is our minimum angle here. So if we're solving for an angle, the inverse trigonometric functions. So let's figure out what we're working with here. Well, the tree is a vertical we treat the tree like a vertical structure, so it must be perpendicular to the ground. So this is where a 90-degree angle is. So TA is the hypotenuse. With respect to angle A, the trees are the opposite side, and the distance to the tree from the astronomer is the adjacent side. So hypotenuse. Let's go back to our scribbles. No hypotenuse, sine and cosine out of the question. Once again, we must rely on tangent. Okay, so rather inverse tangent, since we're solving for the angle measure. So the measure of angle A is the inverse tangent. Tangent is opposite over adjacent, so 19 over 50. Go to our calculators. 19 divided by 50, 0.38, second tangent. And we get 20.80679,101, which rounds to 21 degrees. So the astronomer must have the telescope to at least 21 degrees in order to observe a star. Let's see. Well, it appears that there's a missing problem here, so I might have to address that later from the assignment. So we'll come back to it. If anything, I'll make the lesson specific to the assignment to help you all out. And well, that concludes the video for lesson 8-5. Highly recommend that you work on the remaining examples for practice. We covered the first 3. You have 1, 2, 3, 5 left to do, and I will provide you with an assignment that will feature many more.